Hi guys, welcome back to my YouTube channel, and in today's video I'm going to be teaching you how to identify inorganic compounds. Okay guys, so we know organic compounds as any compound that contains carbon. Okay, so there are four exceptions that where if there's a carbon in the compound, but if any of these four conditions are present, that makes it an inorganic compound, even if there's still carbon in there. So the first condition is if it's a carbon oxide. If there's an oxygen and carbon in there together as a compound, then that means it's inorganic. Okay, carbon and oxygen. And then carbonates. If any compound contains CO3, this is a polyatomic ion. It appears in the periodic table. I'm going to put it on the screen, but there's a section in the polyatomic ions, and if the CO3 from that section is present in the compound, that makes it a carbonate, making it an inorganic compound. Okay, carbides, I'm going to skip over, and I'll show that in the next clip. Let's go to cyanides. So cyanides are also a polyatomic ion, and they appear in the periodic table, and they are shown as CN. If a CN together is in any compound, that means it's a cyanide, making it inorganic. Okay, now let's move on to carbides. I'm going to show you when the carbon acts as an anion in the compound, meaning the carbon carries a negative charge. Okay, guys, so a carbide is defined as when the carbon acts as an anion, making it a negative charge. Okay, so here we have a compound CaC2. You can first, what you're going to do is see what each individual element has, like what the charge of it is. So from the periodic table, we know that Ca has a +2 charge, it's positive. That means our carbon has to be negative to cancel out the charges. So one single carbon atom has a -1 charge. And now you see the subscript, which is 2. You're going to multiply this subscript by -1 and you're going to get a -2 charge on the carbon. So to cancel those out, the carbon must be -2. And that proves that this is acting as an anion, making this compound a carbide. This is inorganic. Now let's move on to another example. Okay guys, so here is our second example of lithium carbide. Here from the periodic table, we know that the charge of lithium is +1, okay? And with the subscript, when we multiply it with the charge, we get, in the compound, lithium has a charge of +2, okay? And in this compound, we know that carbon in its own has a charge of -1. Now multiplying the subscript with the charge, we get carbon has a -2 charge. Again, the carbon is acting as negative, which makes it clear that our carbon is acting as an anion, which is why this is a carbide. Okay, so now we're going to move on and do a set of questions, and you're going to tell me which is organic and which is inorganic. Okay, guys, so here are some compounds, and what I want you to do is tell me which ones are inorganic. So pause the screen and comment down which ones are inorganic and which ones are organic. Okay? Okay, now I'm going to explain which ones are organic and which aren't. So C2H4, this doesn't fall into any of the four categories we studied, therefore this is organic. CaC2, this is a carbide because the carbon is acting as an anion, it's acting as a negative charge. Ca we know has the charge of 2 plus, and we have two carbon atoms, which mean that carbon on its own has a -1 charge, but in the compound it has a -2 charge. So this is a carbide. This is inorganic. Let me circle it 1 second. This one is inorganic. Okay, and HCN. The polyatomic compound CN is in this cyanide, meaning this is also inorganic because this is a cyanide. So this is inorganic. And CuCO3, another polyatomic ion, CO3. This is also in the periodic table, so this makes this a carbonate. So it is inorganic. CO2. Remember, the first group that we studied was carbon oxides. This falls into the same category, so this is also inorganic. And then C8H18. This doesn't fall into any of the four categories, so this is going to be organic. Okay. Okay guys, so that's it for today's video. I kept it short because this is very simple to understand. So if you have any questions, please leave them in the comments. So yeah, see you guys next time. Bye.